Okay, so my name is Billy Olson, and I am from Canonical as well. I do a lot of infrastructure stuff. So what you will see is a clickbaity title here of AI made infrastructure weird again. Well, the truth is that clouds have been making infrastructure weird again, and our friends at like NVIDIA and other places like that have been jumping in on it to make hardware weird. So we were supposed to be escaping hardware, right? From the sense of we have these ideals, cloud computing, virtualization, containers, Kubernetes. Hardware was becoming irrelevant to the average application developer in many different ways. It was just something that you spin up an application on. And of course, it becomes simple from an application perspective, but as we want to run more and more and intensify things at the infrastructure layer, we come up with a lot of different things from a cloud computing perspective or an acceleration perspective where things like the CPUs become the bottlenecks. And so you want to start actually getting different types of cards and accelerators available on the server itself. So you end up having things like SmartNICs, you end up having different accelerator cards. And the really interesting thing is no matter what you have multiple host CPUs, you have these new DPUs that have their own ARM chipsets on it, you have storage controllers that are coming out with their own chipsets on it. And so suddenly, everything within the server is becoming a distributed system. So distributed systems were hard in and of themselves, and so a lot of people will shy away from them because it's like, here's one server, here's another server, how do we actually coordinate time differences across the actual servers? How do we actually have cluster epochs and things like that to make sure that things work well? And that was hard for a lot of people. But now we've taken it and we've put it inside the server for the data center to be able to actually do different things. And we continue to make it more complex. We add different types of compute nodes, whether it's like an accelerator, like an NPU, a TPU, a GPU. They all have their own types of languages that go on there and you have to program. You have PCI devices that talk to other PCI devices that don't include the CPU on the main CPU board that you actually have. So overall, it's really weird. The whole server itself is becoming a volatile distributed system in and of itself. And most of us don't even really think about that. I was talking with someone earlier who called it the zoo, effectively, about kind of like how things are actually coming today in the Silicon Zoo. And so when we take a look at it, we expected this at some point, and we keep adding more devices, more components, more things that just start heating up more and more. And so suddenly the server stopped just being the GPU, it started being a GPU, it started being a DPU, and suddenly it became a facilities engineering problem somehow as we continue to heat these up, right? You can no longer keep these cool just from a perspective of passive airflow or even active airflow that goes through your data center. No, the amount of actual power and stuff that you can get from your actual systems becomes literally down to the pressure of the water and the pipes that you can actually push through the data center to keep things cool. So you have to actually look at not only the power consumption, but the water usage and how to actually keep them cool. So now you have to build systems on top of systems to be able to get your overall AI data center actually coming through, or your data centers coming through to be able to be very productive. And then suddenly once you start looking at those, you have different things that come in there. It's not just scheduling, how do I get this virtual compute instance that I'm trying to launch on a specific server. It's how do I put it in this particular rack that can actually take the power load that I'm trying to actually run in these particular places, and how do I optimize the power load? So suddenly, the actual use of servers and data centers and all that becomes extremely difficult. And we have to start thinking about a lot of things. And so a lot of people start thinking about all this when they're coming up with data centers, right? They think about power, they think about thermals, they think about the topology of the rack and failure domains, they think about latency, and fundamentally, more and more people have to think about physics, and physics and physics and physics. And I think that's something that's really weird, but also really cool. The AI has kind of like pushed us, and the data center's getting so big. I mean, now everyone who wants to build a nuclear power substation gets an AI data center with it, right? Or is it the other way around? I can never quite remember. But this is some of the things I think that's really neat about the way that AI is pushing us is it's really pushing us to change things to where only chip manufacturers used to think about the real physical elements of the silicon and how do you push bits and bytes and electrons across to actually all of our data centers, all of our servers, how do we actually have a variety of different pieces of hardware coming together? And I think it's fundamentally changing the way that we have to think about servers, data centers, everything, even Greg's pocket of, or 2 passport size little Pi stack. So, and that's it.